This is 6.3, all about square root functions. Okay, so overall, this is something we're going to be graphing by hand. All right, our parent function for a square root function is going to look like this. To see this picture, we are going to draw a table. All right, anytime that you're graphing, you can always just make an x, y table. So what values would we want to plug in for x here? How about 0? The square root of 0 is 0. Okay, how about 1? The square root of 1 is 1. The square root of 4 is 2, so I'm going to skip over 2 and 3 because I don't want to worry about decimals. I just want to manipulate it so that I get all integer points, all right? And then 9 and 3. You may be wondering, well, what about -1? What about -2? What about -3? And that brings in the idea of a square root versus taking the square root, right? So if I tell you that x squared equals 25 versus if I'm asking you what is the square root of 25, these are asking two different questions, okay? A number that is being squared to become 25 could be 5 or -5. But if I'm just asking you what is the square root of 25, you should give me 5. You should give me only the positive one. If I ask you what's the negative square root of 25, then you should give me -5, okay? So you're doing two different things here. And in the table, we're dealing with this second question, so we're only going to work with the positives, okay? So we've made our table. Now let's see what our graph is going to look like. Let's plot a point at the origin, 0, 0, 1, 1, 4, 2, and then 9, 3. This is what our graph's going to look like, and it's just going to have a slight curve up like this, all right? There's no arrow on the other end. It just goes up from the origin. This is our parent function, okay? The most basic form of a square root graph, okay? Our domain here, what are possible values for our x's? All right, 0, 1, 4, 9. Could we plug in 1/2? Could we plug in, 1.5? Could we plug in 4.5? If we plug in those positive values, we're going to get numbers, okay? We're going to get real numbers back. So any positive number is just fine, including 0, okay? What about negatives, though? If I plug in -1, I'm no longer going to be working with real numbers. I go into imaginary land. So for our domain, we just want to know what are the real values for x in interval notation. So we can plug anything 0 or greater, anything x is greater than or equal to 0. Or in interval notation, we want to represent that as 0, infinity with a bracket around 0 because we are including it, and a parenthesis around infinity. Another way to look at it is what values on this x-axis are you covering? You're covering 0, and then as you go up to the right, we are covering positive values on the x-axis, okay? For our range, it's saying what about our y's? What are our possible real values for y's? So looking at this graph, this is the easiest way to tell what range is, okay? What are our potential y values as we're looking along our y-axis? We see a 0, and then as this graph continues up, we're going to be going in the positive y direction. So again, we want to see anything greater than or equal to 0 for those y's. In interval notation, it would be 0, infinity. Next, let's try to make a table for this. Okay, x, y. Again, I want to choose values that are going to give us nice integers under our square root. So I'm going to pick perfect squares like 0, 1, 4, and 9. And then I'll get 0, 1/2, 1 here, and then 3/2. So our graph is going to be a little bit flatter. Okay, over 1, up 1/2, over 4, up 1, over 9, up 3/2. So we're still seeing a similar shape. It's just much flatter. All right, our domain is going to be the same, 0 to infinity. Range is going to be the same from 0 to infinity. All right, and again, for domain and range, you're looking to see what are possible values for x's and y's. X is going to be the domain that ends up getting restricted, and it's because we need to have positives or 0 under that radical. Pause the video, try making this table. All right, hopefully your table looks something like this, 0, 1, 4, 9. You're welcome to plug in values in between these. You're welcome to choose non-perfect squares, but you're just going to have decimals, which is kind of not the most fun when we're trying to plot. All right, and then we'll end up with ordered pairs, such as this, 0 over 1 down 2, over 4 down 1, 2, 3, 4, over 9 down 1, 2, 3, 4, 5, 6. Okay, and so when you're deciding where your arrow should go, ask yourself, like, could the graph continue on this way if you plugged in negatives? Like, could you potentially have ordered pairs up here? No, you couldn't. These are negative x values, which are going to give us imaginary numbers under that radical, okay? So we have to make sure that our graph continues on in the other way, the other direction. So our arrow goes like this. So it's kind of, it's reflected, if you will, over the x-axis, right? We have that negative out front. Thinking back to function transformations, we are being reflected over our x-axis. Just in case you're interested, the domain would be from 0 to infinity with a bracket around 0. Same thing for... excuse me, sorry, our range actually is going to be a little different here. Our range, if we're looking at this graph along this y-axis, we're asking ourselves, what are possible values for y? So 0, and then a negative number, right? -2, -4, -6, and then it's just going to keep getting more and more negative. So we're actually dealing with y values that are less than or equal to 0, meaning our range and interval notation is going to be from negative infinity to 0 with a bracket around the 0. Okay, domain's the same because we're still covering these positive values on our x-axis. All right, sometimes you may be given your equation in a little bit different form. I don't really want you to memorize this, but it's just something to be aware of. Okay, something to be aware of, that like wherever the graph starts, we can kind of read that off from the equation. All right, so we're still just going to make a table, and we're going to choose values that are going to give us perfect squares underneath that radical. Okay, so in order to get 0 underneath the radical, so that I can take the square root of 0, I want to plug in 3. Okay, in order to get 1 underneath that radical, because 1 is our next perfect square that's positive. Okay, in order to get 1 under here, I want to plug in 4, right? Because 4 minus 3 is 1. What's our next perfect square that we've been working with? 4. Okay, so how can I get 4 underneath this radical? How can I get 4 underneath this radical? I could just plug in 7, okay, because 7 minus 3 is 4. So this is all just a trick to get some easier numbers to work with mentally, because this is something you're going to need to do without a calculator, okay, or without a graphing calculator, excuse me. What could we get to give us 9 under here? We could plug in 12. All right, so then now we've made our table, and we're going to end up with 4, 6, 8, and 10 when we plug in those values into the equation. Use a calculator or do your order of operations very carefully, okay? Evaluate your square root. So 3 minus 3 is 0. 0 times 2 is 0. 0 plus 4 is 4. Okay, 6 minus 3 is 3. Excuse me, sorry. 4 minus 3 is 1. 1 times 2 is 2. 2 plus 4 is 6. Okay, so just be very careful when you're evaluating that stuff. Let's plot these points. Over 3 up 4. Over 4 up 6. Over 7 up 8. And then over 12 would be over here up 10. Okay, to decide which way your arrow is going to face, check and see, could you plug in x values to the left? Could we plug in 0? If we plug in 0 here, we're going to get 0 minus 3, which is a negative 3 under that square root. That's a no-go. Okay, so because of that, we need to make sure that our arrow on the graph faces the other way. For our domain, let's look and see, where are our x values starting along this graph? Starting right here. Okay, that x value is at the point 3. Okay, x equals 3. So we're going from 3 all the way up to positive infinity. We want a bracket around 3 and a parenthesis around infinity. For our range, we are starting at 4. Okay, we are starting at 4 and we are moving up. See that? So we're starting at 4 and we are moving up in the positive infinity direction. We want a bracket around 4 because this point is included, and we want a parenthesis around infinity. Another way you could get that domain without looking at its graph, you could say, okay, I need x minus 3. I need that part under the radical to be greater than or equal to 0, meaning I need x to be greater than or equal to 3. For range, I'm just going to suggest that you look at the graph because it's easier. Okay, sketch yourself a little graph and see what you end up with. Pause the video, try this example. Okay, hopefully you have something like this. So to get those perfect squares underneath the radical, we're going to want to choose these values because 2 minus 2 is 0, 0 plus 5 is 5, 3 minus 2 is 1, 1 plus 5 is 6, 6 minus 2 is 4, square root of 4 is 2, 2 plus 5 is 7, 11 minus 2 is 9, square root of 9 is 3, 3 plus 5 is 8. Okay, and then now we plot our points over 2 up, 1, 2, 3, 4, 5. Over 3 up 6, over 1, 2, 3, 4, 5, 6 up 7, should be right there, and then over 11 will be a little bit off the graph, that's okay, up 8. To decide which way our arrow goes, ask yourself, can you plug in values on one side or the other? So can we plug in 0 here? No, because we would get square root of negative 2. Okay, so our graph goes up like this. For our domain, we want to see what values of x do we need to make sure we have in order to make sure that we're taking positive square roots. Well, we need to make sure we're greater than or equal to 2, and that checks out, right? Because if we look along this x-axis, we're starting our graph here at 2. So we want 2 up to infinity with a bracket around 2. Range, we are starting over here at 5. And then we are moving up. Okay, see how that graph is moving up in the positive infinity direction with a bracket around 5 and a parenthesis around infinity. Last one. Let's make our table. Okay, if you're struggling with what to put here, just start with whatever makes this part under the radical equal 0. Okay, in order to get 1 underneath this radical, in order to get 1, we need to plug in a negative 2. In order to get 4, we need to plug in 1. Okay, and in order to get 9, we need to plug in 6. So our perfect squares. And then if we evaluate, we should get these values. Just be very careful when you're doing that. Follow your order of operations very closely. Graph these points. 3, negative 1, 2, negative 3, 1, negative 5, and 6, negative 7. Okay, to decide which way our arrow is going to face, ask yourself, can you plug in a number like down here? Can we plug in negative 10? Negative 10 plus 3 would give us negative 7? No, we cannot. So we have to make sure that we choose the side that negative 10 is not included on. Okay, so our curve is going to be a little bit like this because we're seeing, again, that negative out front means we're reflected over the x-axis. That's why our curve looks like this instead of like this, like the other ones. All right, and then our domain, what is going to ensure that we keep x plus 3 greater than or equal to 0? Values of x that are greater than or equal to negative 3, okay? We can see that by asking which portion of the x-axis are we including. We start at negative 3 and we're going onward to positive infinity, so we want negative 3 comma infinity. With a bracket and a parenthesis. And then for our range, we want to see what part of our y-axis are we using. So we're starting here, which is at the y value, negative 1. And then we are going down to negative infinity, okay? So in math, the way that we represent negative infinity is that we write it first, okay? Negative infinity in interval notation, comma, negative 1, with a bracket around negative 1 and a parenthesis around negative infinity. Take a look at your practice and let me know what questions you have.